In this lesson, we're going to be looking at the trig ratios, which are going to be the ratio of the sides of right triangles with respect to one of the acute angles in the triangle. So, in this figure, theta is referencing the measure of the angle, the indicated angle. With respect to that angle, theta, A would be the opposite side, B is the adjacent side, and C is the hypotenuse. The hypotenuse is always the side opposite the right angle. The ratio of sine is the opposite side over the hypotenuse. And again, this is always with respect to the angle that's indicated. Cosine of the angle indicated is its adjacent side over the hypotenuse. Tangent of the angle measure. Let's throw in that grease symbol, theta. So tangent of theta is going to equal the opposite side, the side opposite the theta angle measure, over the adjacent side, the side adjacent to that theta degree angle. And cosecant is just the inverse of sine. Secant is the inverse of cosine. And cotangent is the inverse of tangent. Acronym that you guys can use to remember these three main trig ratios is SO, CA, TOA. SO, sine is opposite over hypotenuse. CA, cosine is adjacent over hypotenuse. TOA, tangent is opposite over adjacent. All right, in this figure example, we want to find sine of theta. So the ratio for sine is opposite over hypotenuse. The side that is opposite the theta, angle theta, is 9, and the hypotenuse in this triangle is 15. So sine of that angle measure is 9 over 15, which can be simplified to 3 over 5. In this figure, we want to determine what the cosecant of that angle measure is. Cosecant is the inverse of sine. And since sine is opposite over hypotenuse, the inverse of opposite over hypotenuse is hypotenuse over opposite. The side that is the hypotenuse is not given, so as long as we have the measure of two of the sides of a right triangle, we can use the Pythagorean theorem to find that measure of the third side. So we're going to square the two legs, add up those squares, set that equal to the square of the hypotenuse. 8 squared is 64. 8 root 3 squared. 8 squared is 64. Root 3 squared is just 3. 64 times 3 is 64 times 3 plus 64 is going to give us 256. Square root of 256 is 16. So the hypotenuse is 16. So cosecant of theta is going to be 16 over the opposite side, which is 8 root 3. We just need to rationalize that denominator by multiplying the numerator and denominator by root 3. That'll give us 16 root 3 over 8 times 3. 8 divides into 16 2 times. 2 root 3 over 3 is what the cosecant of that angle measure would be. All right, for this one, we're told sine of theta is equal to 2 root 14 over 15. I want to find out what cosine of theta is. Now, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. All right, so I should probably start with, you can draw a right triangle. All right, so the adjacent side squared plus the opposite side squared, which is 2 root 14 squared, equals the hypotenuse squared, 15 squared. When I square 2 root 14, I get 4 times 14, which is 56. 15 squared is 225. Subtract 56 from both sides, and I get 169. Square root of 169 is 13. So the adjacent side is going to be 13. Plug that into the numerator for the equation on the left. Cosine of theta is going to equal the adjacent side, which is 13, over the hypotenuse, which is 15. We want to find out what theta is for this figure. So we always want to reference the angle that we're trying to find with respect to that angle measured theta. 5 is opposite that angle, and 6 is adjacent to that angle. Opposite and adjacent are the two parts that we need for tangent. Tangent is opposite over adjacent. So the tangent of that angle measure will equal the opposite side over the adjacent side. Opposite side is 5, adjacent side is 6. And since we're trying to find the angle measure, we want to, in essence, we're going to divide both sides by tangent, or take the inverse of tangent to isolate that theta. So theta will equal the tangent inverse of 5 over 6, or arctangent. And once we plug that into our calculator, arctangent of 5 over 6 is approximately 39.8. All right, so we want to find all the unknown, the angles, and the sides that are not already given. Let's start with the angle. The acute angles in a right triangle, they always add up to 90. So to find angle B, we just subtract 47 from 90. So the measure of angle B is going to be 43. And now we can use the trigonometry to find the other two sides, given that 47-degree angle. So with respect to that 47-degree angle, BC is opposite that angle, and AB is the hypotenuse. So to find AB, I would set it up as the sine of 47 equals the opposite side, 12.41, over the hypotenuse. And I can just flip-flop the sine 47 and the hypotenuse. So when I divide 12.41 by the sine of 47, I get approximately 17.0. And then for AC, AC is adjacent to the 47-degree angle, and 12.41 is still opposite that angle. Opposite over adjacent is tangent. So the tangent of that 47-degree angle equals the opposite side over the adjacent side. Again, flip-flop the adjacent and the tangent of 47. And the adjacent side is going to equal 12.41 divided by tangent of 47, which is approximately 11.6. And then lastly, we're given the measure of angle B and one of the sides, A. Should start by drawing a figure. We're also told that C is the right angle. So if C is the right angle, then the hypotenuse is lowercase c. A and B are the other two acute angles. And side A is always opposite angle A. Side B is always opposite angle B. So start with the acute angle. Angle A is just going to be 90 minus the other acute angle, 33, which is 57. And then to find B, B is opposite angle B, which is 33 degrees. So side B is opposite angle B, and A, we're given the measure of, that's adjacent to angle B. Opposite over adjacent is tangent. So tangent of that 33-degree angle equals the opposite side over the adjacent side. To solve for b, we would just multiply both sides by 2. And once we find out, you would first plug in tangent of 33 in your calculator, and then multiply that result by 2. You get approximately 1.3. You should still always use the angle measure that's given in the problem. So with respect to the angle B, which is 33 degrees, A, which is the adjacent side, it's given, it's 2. And then to find C, which is the hypotenuse, that would reference cosine, the cosine ratio. All right, so cosine of angle B equals the adjacent side, which is 2, over the hypotenuse, which is C. So we want to flip-flop the C in cosine of 33. And C is going to equal 2 divided by the cosine of 33, which is approximately 2.4.